Okay, so this is going to be free response note set number 7. Some of these problems might be familiar because I might have used them whenever we were doing other things and I didn't realize it. So if they're repeat problems, sorry, but it's not going to hurt you to do them again. Okay, so fish enter a lake. So this is what's entering. Fish leave the lake at a model of L of t, so that's leaving. And they're measured in fish per hour. So t is equal to 0 is at midnight. Okay, question A. It says how many fish enter the lake over a 5-hour period? So we're going to integrate from 0 to 5 of E of t. Okay. Remember, when we integrate a rate, we get an amount. Okay. So this is going to be 20 plus 15 sine. Ooh, let me go ahead and delete those. So it's going to be 20 plus 15 sine of pi x over 6. Quit. Okay, so we're going to integrate math 9 vars y1 comma x comma 0 comma 5. And we should get 153.457. 153.4577. Now it says round to the nearest whole number fish, so it's going to be 153 fish. Okay, so that's how many fish enter between 0 and 5 hours. Okay, what is the average number of fish that leave the lake over a 5-hour period from 0 to 5? Okay, so average amount, average value is 1 over b minus a, so 1/5, the integral from 0 to 5 of L of t. Okay, so I'm going to put my L of t in y2. Okay, so L of t is 4 plus 2 to the power of 0.1 x squared. We're going to quit math 9 vars. We put in y2, comma x, comma 0, comma 5. Did I put in y2? I put in y1. Crap. Okay. Let's change it. Accidentally deleted. Okay. And then we got to divide by 5, so, or multiply by 1/5. So you get 6.059. Okay. This one doesn't say round to the nearest whole fish, so we're going to leave it as a decimal. Part C, it says, at what time t is the greatest number of fish in the lake? Okay. So when we're looking for a max or min, we're going to be looking at the derivative, okay? So our derivatives, we have things entering and we have things leaving. So we're going to call this an accumulation function, okay? So the entering is E of t, and we're leaving, so it's L of t. And we want to figure out where that's equal to 0 so we can find our critical points, okay? So I'm going to do 20 plus 15 sine of pi x over 6 minus, I'm going to use parentheses, 4 plus 2 parentheses 0.1 x squared, and I'm going to close parentheses. Okay, and I want to know between 0 and 8, so I'm going to change my window from 0 to 8. And I'll change my window from 0 to 8 in just a second. Okay, so window 0 to 8, graph it. So when I find these zeros, I'm going to find my intersection points. I mean my zeros. So that gives me my critical points. I'm going to keep going down and hit enter again. So I get t is equal to, so my critical point is t is equal to 6.2035. Now, this is an absolute max and absolute min problem. Okay? So absolute max. Okay? So what we're going to do is when we do absolute max and min problems, we have to consider our critical points and we have to consider our endpoints. So our endpoints are going to be 0 and 8. Okay, so we're given the rate to find the amount. Okay, we're going to integrate from e of t minus L of t dt for each one of those to figure out which one's going to be the greatest amount. 0 to 6.2035. Okay, so we're going to use our calculator for this. So if we integrate from 0 to 0, we get 0. If we integrate from 0 to 8, so math 9 vars y1 comma x comma 0 comma 8, you get 80.9199. And if I integrate from 0 to 6.2035, okay, I get 135.01. 149. Okay, so this is going to be your absolute max. And this would be your absolute min if it asked that. Okay. Part D. It says, is the rate of change in the number of fish in the lake increasing or decreasing at t is equal to 5? Okay. So as soon as I see the word increasing, decreasing, that means we're going to take a derivative. Okay. Now, that means we're going to be taking the derivative of the rate of change, which is your e of t and L of t. Okay, so a prime of 5 is equal to e prime of 5 minus L prime of 5. Okay, so we already have that function in y1. So we're going to do math 8 vars y1 comma x comma 5. Okay, so you get negative 10.7228. Okay, now since it's negative, it's decreasing at t is equal to 5. Okay, next question. Okay, it says the velocity of a particle moving along the x-axis is given by the table, pretty much, Vp of t. Okay, it says justify why there must be at least one time where v prime of t is equal to 0 in between 0.3 and 2.8. Justify your answer. Okay, so this is going to be MVT. MVT says that it must be continuous and differentiable. So just write those two words in there. And it also says that f prime of c is equal to, now we're going between 0.3 and 2.8. So f of 2.8 minus f of 0.3 all over 2.8 minus 0.3. So f of 2.8 is 55. F of 0.3 is 55 over 2.5, which is equal to 0. Therefore, MVT guarantees at least one C where v prime of t is equal to 0. Okay, and that's how we fully answer that question. Part B says use a trapezoidal sum from 0 to 2.8 to approximate the integral. Okay, so start out and do our delta x's up there. So we get 0.3, 1.4, and 1.1. Now we're only going from 0 to 2.8, so make sure you pay attention to that. So B, part B, so we're going to have 1/2 times 0.3 times 0 plus 55 plus 1/2 times 1.4 and 55 minus 29 plus 1/2 times 1.1 times negative 29 plus 55. Okay. When you put those in the calculator, you should get 40.75 meters. Okay, C. Second particle Q moves on, so the velocity function is given like that. Find the time interval during which the velocity is at least 60 miles per hour. Okay, so the word at least means it's greater than or equal to 60. Okay, then find the total distance traveled by particle Q during that time interval where it's at least 60. So what we're going to do is we're going to put that VQ function into y equals 45 square root of x cosine of 0.063 x squared. And then we're going to put the line y equals 60. Now I want to change my window. Let's change our window to like 80. Okay, our y window to 80. And it says our x window needs to be 0 to 4. So we can get a good idea what this graph's going to look like. Okay, so we can see from the graph that it's going to cross here and here, so we need to find those two intersection points. Okay, so I get t is equal to 1.866. And we're going to do calc 5, intersect again. And I get 3.5192. Okay? So we know that it's going to intersect at 1.866 and 3.519. Make sure you go at least 3 decimal places on this stuff. So total distance traveled is equal to the integral from 1.866 to 3.519 of the absolute value of your velocity function. Okay, so what we're going to do is we're going to hit Math 9, vars. Now we got to do absolute value. So do math, absolute value of y1, close parentheses, comma x, comma 1.866, comma 3.519. You should get 106.109 meters. Part D, it says at t is equal to 0, the position of Q is negative 90. Using the result from part B and the function VQ from part C, approximate the distance between the particles at t is equal to 2.8. Okay. So to get a displacement, which that's what we're looking for, distance away from each other, displacement, we have to integrate the velocity function. So we're going to go from 0 to 2.8 of Vp of t dt is equal to x of 2.8 minus x of 0. Okay, so we know that this integral from part B is 40.75. And its initial position at 0 is 0 because it says that t is equal to 0. It's at the origin. Okay, so xp of 2.8 is equal to 40.75. Okay, now we got to do the same thing for the q particle. Okay, so we're going to integrate from 0 to 2.8. Vq of t dt is equal to xq of 2.8 minus xq of 0. So we're going to integrate this stuff. Now we're going to do math 9 vars y1 because our VQ is in there, comma x, comma 0, comma 2.8, close parentheses. So you should get 135.9376. Okay. Okay, xq of 2.8 is what we're looking for. xq of 0, it says it has a position of a negative 90. Okay, so I'm going to end up subtracting that to the other side. So you get 45.9376. So I want to know the distance between these two particles right here. So I'm going to subtract them. Okay, so that means that they're 5.1876 meters apart. Okay, so that's how we do this question. A little bit different from some of the stuff we've done before, but not too different. Make sure you remember that total distance traveled is the integral of the absolute value. Okay, this is one question, or we've done a version of this question, I can't remember, but we're going to do it again. If we have, okay, so we're given a piecewise function, and this is the graph of f. Okay, it says if the integral from, so it says we're only given from -6 to 5, and that's a quarter circle. So it says part A, if the integral from 5 to -6 of f of x dx is equal to 7, find the value of the integral from -6 to 2. Okay, now if we're going the whole entire integral, it's going to be this right here. So we got to keep that in mind. So we're going to break it up into two little portions. Now remember this little property of integrals. That if these two limits match, that we get the integral like this. And we add them. Now, if you have to flip it, then you have to make it if you flip your limits, you have to make it a negative sign. Now, they always have to match going this way. Okay? So we're looking for this. The integral from -2 to 5 is this area under the graph up here. Now, to save yourself some trouble, okay, so pay attention to this. This area is equal to this area down here, okay? This area is equal to this area. So really all you have to do is find this shaded region right here and right here. Okay, so we're going to start with the trapezoid. So we got a trapezoid. Area of a trapezoid is 1/2. Your base is 1. Your height is 1. Your other base is 1, and the other base would be 3. So your area comes out to be 2. Now, this is the tricky part. And we've already done some questions like this, so it's not too bad. So we have a square. Remember, the integral is the area under the curve. So area of a square is going to be the side squared. So this is going to be 3 times 3 is 9 minus. Now you got a quarter circle. So the area of a quarter circle is pi/4, and it has a radius of 3. So the area of that region is going to be 9 minus 9 pi/4. So that's from 2 to 5. Now, the total area from -2 to 5, with these canceling and all that other good junk, is going to be 11 minus 9 pi/4. (11 - 9 pi/4). And it says that this whole integral right here is going to be 7. So solving for this, right here, we're going to subtract the 11 and move that over. We should get 9 pi/4 minus 4. Part B. Okay, so we want to evaluate the integral from 3 to 5 of 2 times f prime of x plus 4 dx. So what we're going to do is we're going to split that into two separate integrals. Okay, so remember the integral of f prime of x is equal to f of 5 minus f of 3. And the integral of 4 is 4x, and I'm going to evaluate it from 3 to 5. So from my graph, f of 5 is equal to 0. F of 3 is given to you in this point right here, so it's 3 minus square root of 5. Okay, and this is going to be 20 minus 12 should come out to be 8. Now, I would distribute this negative out and then multiply by 2. So this comes out to be a negative 6 plus 2 square roots of 5 plus 8. So your final answer is going to be 2 plus 2 square roots of 5. Now, you could have left it like this. That's just considered arithmetic. It's not considered algebra or anything like that. So part C, it says given g is the function is the integral. Find the absolute max and absolute max value on this from -2 to 5. So we do absolute max and min problems. We first got to find your critical points. So your critical points occur where the derivative is equal to 0. So if I take the derivative of an integral, I get the original function. Okay? So this is pretty much a derivative graph. So your critical points occur at the zeros. Okay? So your critical points are x is equal to a -1 and x is equal to, is that 1/2? Yeah, 1/2. And your endpoints are going to be -2 and 5. So on absolute max and min problems, we always have to consider our endpoints and our critical points. So we have to do the integral from -2 to, so we got to go through and do all these. Integral of -2 to, so g of -1 is equal to the integral from -2 to -1 of f of x dx. So the area from -2 to -1 is going to be a triangle, so it's going to be 1/2. The integral from -2 to 1/2. Okay, so if I integrate from -2 to 1/2, we already said that this area is going to cancel, and then it looks like we have a triangle here, so it's 1 by 1/2. So the area of that triangle is going to be 1/4. We're going to do g of 2 is equal to, sorry, -2. G of -2 is going to be the integral from -2 to -2 of f of x dx, which is equal to 0 because you don't change your limits. And g of 5 is equal to the integral from -2 to 5 of f of x dx. We already found that. Where do we find that at? Is going to be 9 pi -2 to 5. Where's it at? Didn't we just do that? It's going to be 11 minus 9 pi over 4. Okay, so we're looking for the absolute max, and I'm going to say that, let's see, 9 pi over 4. Yeah, so this is going to be your absolute max. Okay. Remember, pi is about 3, so 3 times 9 is 27. 27 divided by 4 is going to be 5 point something, so it's going to be around 6. So that's going to be your absolute max. Part D. Okay, I'm going to go up here and do part D because I ran out of room. Okay, so part D. It says you want to evaluate the limit as x goes to 1 of this. So 10 to the 1 power minus 3 f prime of 1 all over f of 1 minus arctan of 1. Now this isn't a L'Hopital's rule question because you don't get 0 over 0. But a lot of times your L'Hopital's rules will look like this. Okay, so f prime of 1 is the slope at 1, so it's up 1 over 1/2. So it looks like it's going to be 2. Because 1 divided by 1/2 is 2. Or you can count up 2 over 1, up 2 over 1. And then f of 1 is 1. Arctangent of 1 is pi over 4. So 10 minus 6 is 4 over 1 minus pi over 4. You get your answer. Okay, this question we've done a couple times, I think, maybe, or something like it, similar. So let's make sure we do this kind of quickly. It's a related rates question and a differential equation. It says find the rate of change of the volume of the cylinder. So volume of a cylinder is pi r squared times h. Okay, we have a product rule whenever we take the derivative of this. So we write the first term, derivative the second. Pause, write the second term, derivative the first. dr dt is equal to 0 when we deal with the cylinder. Okay, so we get dv dt. Okay, your radius is going to be 1 because half of the diameter is going to be your radius. And dh dt is going to be a negative 1/10. And it says the height is going to be 4 feet. Okay, so square root of 4 is 2. 2 divided by 10 is 1/5. So it's going to be a negative pi over 5 cubic feet per second. Part B, it says when the height of the water is 3, is the rate of change of the height of the water with respect to time increasing or decreasing. So anytime I see the word increasing or decreasing, I'm going to take another derivative. So it's asking me at what rate is the first derivative changing. So we're going to find our second derivative. So it's going to be negative 1/10. The derivative of square root of h is going to be 1/2. H to the negative 1/2. And we're going to follow it by dh dt. Okay, now we know what dh dt is. dh dt is that up there. Okay, and I want to know at when the height is equal to 3. Okay, so 3 to the negative 1/2 means it's on bottom. Square root of 3 is on top. They're the same thing, top and bottom, so those are going to cancel. So we get 1 over 200. And it's going to be increasing because it's positive. Part C is a differential equation. It says at t is equal to 0, the height of the water is 5 feet. Use separation of variables to find an expression for h in terms of t. So we're going to say dh dt is equal to a negative 1/10 square root of h. Okay, we're going to get all our h terms on one side. And I'm going to leave everything else on the other side. Integrate. So we get 2 square roots of h on this side remember to write that as h to the negative 1/2 power and then integrate it. It's equal to negative 1/10 t plus c. We're going to plug in 5 for our h. So we get 2 square roots of 5 is equal to a negative 1/10 times 0 plus c. So c is equal to 2 square roots of 5. Okay, now we're going to divide everything by 2 to solve for h. And then to solve for h, we're going to square both sides. Leave it like that. That's it. We should be good at solving differential equations. Solids revolution. Okay, if this is a non-calculator one, which this is a good non-calculator question, how do I determine which one's which? Okay, so if I was to plug in a 0, okay, so if I plug in a 0 here, cosine of 0 is 1, so 1 times 3 is 3, 3 minus 2 is at 1. So that means that this is your g of x. It's where it crosses the y-axis at x is equal to 0. Okay, and this is your top curve. So area is the integral of top curve minus bottom curve. So 6 minus 2 times x minus 1 squared minus, you need parentheses, negative 2 plus 3 cosine of pi over 2 x dx. Okay, when we go to do this, I'm going to distribute this negative out and combine some like terms. So we get 8 minus 2x minus 1 squared and minus 3 cosine of pi over 2x dx. And we're gonna, our limits are from 0 to 2. Okay, integral of 8 is 8x. The integral of this, we have a simple u sub. Your u is going to be x minus 1. Your du is going to be dx. This becomes the integral of u squared. Okay, integral of u squared is 1/3 u to the third. Don't forget the 2 in front. Okay, and then on this next part, your u is going to be pi over 2 x. Your du is going to be pi over 2 dx. You don't have the pi over 2, so we're going to multiply by the reciprocal and get rid of it. So we get 6 over pi. And the integral of cosine is a positive sign, so it's minus 6 over pi sine of pi over 2x, and we're going to be going from 0 to 2. Okay, so we're going to plug in a 2. So we get 16 minus, plug in a 2, 2 minus 1 is 1. We get minus 2/3. Sine of pi, when we plug in, is 0. And then I plug in a 0. 0. 0 minus 1 is a negative 1. Negative 1 cubed is a negative 1. Negative 1 times 2, negative 2/3 is a positive 2/3. And then sine of 0 is 0. Okay, so this becomes 16 minus 4/3, which is going to give me 44/3. We do around the world. Watch those negative signs. Okay, B. Says region R is the base of a solid, and each cross section is perpendicular to the x-axis. I'm going to find the volume of the solid. So volume is going to be the integral of area. We have x limits. Okay, so the integral of 1 over x plus 3 is natural log x plus 3 in absolute values from 2 and 0. So natural log of 5 minus natural log of 3. Okay, and you can drop the absolute values after you evaluate, so natural log of 5/3. remember that when you do logs and their subtraction, you can combine them by division. Last portion. It says write but do not evaluate an integral expression whenever we go about the line y is equal to 6. So 1, 2, 3, 4, 5, 6. It's up here. Okay, so I'm just going to draw it all the way there. My letter. And then we're going to have an R big and an R little. Okay, so your R big. So R big is going to be top curve minus bottom curve, the whole length. So that's y is equal to 6. So 6 minus g of x. And R little is going to be 6 minus h of x. Okay, and then we can just plug into our formula. R big squared minus R little squared. And I would just leave it as g of x and h of x. If you want to, you can write that in there. Just make sure that you write it correctly, use parentheses correctly. No need to simplify anything. Okay. Okay, we're pretty much going to work the first 3 parts of this question. Because it gets a little tricky towards the end. And D is squeeze theorem, and realistically, you're not going to be asked anything about squeeze theorem. So, okay, part A. It says h prime of 2. So that's the slope of the tangent line at 2. It says the line y equals 4 plus 2/3 times x minus 2 is tangent to both the graph of g and h. So that means it intersects, okay? So that means that the 2/3 is going to be your slope. So h prime of 2 is equal to 2/3. Nothing more than that. Part B. You're given a of x is equal to 3x cubed h of x. And I want to find the derivative of it, and then I want to plug in. So we're going to do product rule. So write the first, derivative of the second, plus write the second term, derivative of the first term, and then we're going to plug in a 2. Okay, so h prime of 2 is 2/3. H of 2 is 4 from the top of the problem. Okay, the 3's will cancel there. 16 plus 144 gives you 160. Okay, part C, it says the function h satisfies x squared minus 4 over 1 minus f of x cubed. It is known that the limit x approaches 2 can be evaluated using L'Hopital's rule. Okay, so this is tricky. So remember, L'Hopital's rule, you have to get 0 over 0 to be able to do this stuff. So we're going to say so if we plug in a 2, we get in this question, you're looking for f of x and you're looking for f prime of x. Okay, so it says that the limit is going to approach 4. And this is tricky because it's going to approach 4 because of this right here. It says h of 2 is equal to 4. So if you're not paying attention to that, then you're not going to get it. So the limit as x approaches 2 of x squared minus 4 all over 1 minus f of x cubed is equal to 4. So what we're going to do is we're going to plug in a 2. Okay, so 2 squared is 4, 4 minus 4 is 0. So what we're going to do is we're going to cross multiply. So we get 4 times 1 minus f of x cubed is equal to 0. 0 divided by 4 is going to be 0. Okay, subtract the 1. Okay, divide by -1. So f of x, when we go and take the cube root, is equal to 1. Okay, so that means f of 2. So let's change that to a 2. So f of 2 is equal to 1. Okay, at that point. Now, when we go to find our derivative, f prime of 2, we're going to use L'Hopital's rule in this. So the limit as x approaches 2 of 2x over derivative 1 is 0 minus 3 times f of x squared times f prime of x. And that's also equal to 4. So what we're going to do is we're going to plug in our 2. So we get 4 over -3. F of 2 was 1. Okay. So we're going to go solve this. Cross multiply. So 4 is equal to -12 f prime of x. So f prime of 2 comes out to be equal to a -1/3. And we're not going to worry about part D. So this is tricky. This was tricky. Now, what you have to pay attention to is we know that the limit has to be equal to 4. Okay, it has to approach 4. If you don't get that part, then you don't get the rest of the problem. You don't get any of the problem right, no matter how well you know L'Hopital's rule. Okay, part 7, number 7. This is going to be for BC only, pretty much. So AB, you're done. In BC, we got 2 problems left to do. So it says part A. Find the value of k for which k is greater than 0 such that the slope of the tangent line to the graph at x equals 0 is equal to 6. Slope of the tangent line is your derivative. So we've got a quotient rule, so we're going to write the bottom, derivative the top, minus write the top, derivative the bottom, okay, all over the bottom square. And that's equal to 6. Anything times 0 is 0. So I get a -2x plus 2 all over x squared minus 2x plus k. So our whole goal is to find what k is when x is equal to 0. So we're going to plug in a 0. Okay, so we get 2 over k squared, because that goes to 0, that goes to 0. So we get 6k squared is equal to 2, k squared is equal to 1/3, k is plus or minus square root of 1/3, and it has to be positive, so we're going to use that. So that's our value of k that satisfies that. Part B. Okay, so I'm going to choose a value of k is a -8. So if I plug in -8 up here for k, we get a function that looks like this. Okay, so the bottom factors, so this is going to be a partial fractions. Okay, and your partial fractions is going to be a over x minus 4 plus b over x plus 2. Okay, we cross multiply. So you only do this whenever the bottom factors. Okay, we're going to collect all our x terms. And that's equal to 0 because there's nothing up there. your constant terms, 2a minus 4b is equal to 1. Okay, so when we go to solve this, we're going to use elimination. I would eliminate the b, so you multiply the top by 4. So we get 4a plus 4b equal to 0. 2a minus 4b is equal to 1. So we get 6a is equal to 1, so a is 1/6. Plugging back in, so that means b is equal to negative 1/6. Okay, so it says we want to evaluate the integral. So we're going to do 1/6 over x minus 4 minus 1/6 over x plus 2. And we're going to integrate from 0 to 1. Okay, both of these are going to go to natural logs. So it's 1/6 natural log of x minus 4 minus 1/6 natural log of x plus 2. Simple u subs. Okay, so we're going to plug in our 1. So we get 1/6 natural log, absolute value of negative 3 is 3. Plug in a 1, natural log of 3. Plug in a 0, 1/6 natural log of 4 minus 1/6 natural log of 2. Okay, these cancel. And if you want to leave your answer like this, you can, or you can distribute out the negative. And that's it. Okay, next question. It says for k is equal to 1, I want to evaluate this integral. So we'll get something that looks like this. Now I know that this is going to factor to the integral of 1. So we're integrating this like that. X minus 1 times x minus 1. Okay. So when we have a rational function and we're integrating, we got to make sure that you don't have any discontinuities. So you're going to have a discontinuity at x is equal to 1 because that'll equal to 0. So that's what makes it improper. So when we set up our improper integral, this is going to be the limit as t goes to 1 from the minus side from 0 to t. So you always go to your discontinuity, 0 to t of 1 dx over x minus 1 squared plus the limit as, we'll say it's s, 1 from the positive side, and we're going to go from s to 2. Okay, so when we go to integrate this, it's going to be the same integral for both of them. It's just we're going to, when we plug in, it's going to be a little bit different. So your u is x minus 1, your du is going to be dx. Okay, so we have the integral of u to the negative 2, which is negative 1 over u. Okay, you add 1 to the exponent, divide by the new exponent. So what's going to end up happening is get negative 1 over x minus 1. We're going to evaluate from 0 to t. And 2 to s. Now, remember, our limit as t goes to 1 is going to be a 1. So I'm getting a little tired. Okay, so when we plug in a 1 here, for our limit as t and s, they're both going to be 1. So 1 minus 1 is 0. So you can't have division by 0. So this is going to be divergent. Okay, and that's all you have to say for that. Okay, last question. Now, this is a good question. I would make sure that I know how to do this. And interpret graphs and read graphs and tables using Taylor series. Okay, so it says write a third degree Taylor polynomial about x is equal to 0. Okay, f of 0. Okay, so we need to find f of 0, f prime of 0, and we have the rest of the information in the table right there. So we can get it from the graph. So f of 0 is 3. F prime of 0 is going to be the slope of the line. Okay, so down to over 1 is a -2. Okay, so that's how we're going to use our graph and our table to help us out. So T3 of x is we write the first term minus 2x. Okay, we're going about 0, so it's going to be a Maclaurin series. Plus 3 over 2 factorial x squared minus 23 over 2, 3 factorial x to the third. Okay. And if I want to simplify this, it's 3 minus 2x plus 3/2 x squared minus 23 over 12 x to the third power. 3 factorial is 6, 6 times 2 is 12. Okay, that's it. Part B. Let's write out the first 3 non-zero terms for the series e to the x. And then I want to multiply it by f of x. And I want the second degree Taylor polynomial. Okay, so we're going to use this for the second part. So e to the x, let's call that g of x. So we don't get confused. So g of x is equal to e to the x. G prime, e to the x, g double prime, e to the x, g triple prime, e to the x. Okay. Now we plug in our 0. Okay, we get 1 for everything. So our Taylor series for this, for e to the x, is going to be 1 plus x plus 1/2 x squared plus 1/6 x cubed. Okay, so it's going to follow your factorial pattern on the bottom. 1 factorial, 2 factorial, 3 factorial. Now it says you want to multiply and you want to get a second degree polynomial. Okay, so what I'm going to do is I'm just going to take the first 2 or 3 terms. Anything over an x squared isn't going to be in my answer. Okay, so I'm going to take 3 minus 2x plus 3/2 x squared from the top right here. And I'm going to take the first 3 terms from that. Okay, so I'm going to FOIL this out. And so I'm going to go 3 plus 3x plus 3/2 x squared, negative 2x minus 2x squared minus x cubed plus 3/2 x squared plus 3/2 x cubed plus 3/4 x to the fourth. So anything over the second degree, I'm just going to cross out. Okay, and I'm going to go through and combine my like terms, and you should get 3 plus your x terms. 3x minus 2x is x. That's right, plus x, okay. And then your x squared terms. So we get 3/2 plus 3/2 is 3 minus 2 is just x squared. Okay, so that's how we answer part B. So it says for the second degree, okay, so we don't want to deal with anything above the second degree. Okay, last part, part C. Part D we're not going to do. Okay, so it says I want to use the Taylor series found in part A, and I want to use it to evaluate the integral of f of t. Okay, so h of x is going to be equal to the integral of this. So it's going to be 3x minus x squared plus 1/2 x to the third minus 23 over 48 x to the fourth. And what I'm going to do is I'm going to evaluate from 0 to 1, okay, because I want to approximate h of 1. So that means I'm going to plug that in, okay? So if I plug in my top limit, 3 minus 1 plus 1/2 minus 23 over 48. If I plug in a 0, I get a 0. Simplifying this, you get 2 plus 1/2 minus 23 over 48. It's 5/2. Common denominator, get a 24. It's 120, so it's 97 over 48. Not the nicest number, but it came out to be nice and neat. Okay, so make sure you pay attention to this stuff. Taylor series, we should be pretty good at doing Taylor series by now. So if you have any questions, feel free to reach out. Have a good night.